My name is Andrew, and I will be talking tonight about the automotive industry and data science in it. Is it working? Yeah, great. So, as my presentation was shortened a little bit, I have a little proposition for you. My presentation consists of basically two parts. In the first part, we will look at the automotive industry as a whole, we'll look at some new technologies, etc. I will shorten this part because the second part is a real data science project within the automotive industry. It will be probably something you have never ever seen before. So I will try to walk you through it very slowly, explain like what's on the slides, but this is the presentation that the management received, so we should be able together to come to a conclusion and to see like how these projects are made. Because most of the time people come to me and say, okay, I have this great idea, we can use like the new neural networks to process some images and to identify, for example, defects in some car parts, and they're like, okay, let's do this, but this is just one small part of the whole package we deliver, so I wanted to stress that. So does it sound good to you? Okay? Okay. So a little context about me. I have been working as a data scientist for the past 6 years. I specialize in automotive industry or in manufacturing in general. However, as I currently work in a company called Trask Solutions, and Trask works like 80% with financial services or fintech basically, and 20% with automotive, I'm shifting a little bit. Last but not least, the most important part, I love Python. I basically do like 70% of my work in this language. The rest, the 20% is SAS, which is really established in the banking industry, and 10% are, you know, just little experiments, some front-end stuff, which I hopefully can do with Dash in the second part. So I'm thinking I will learn something new. So, but before we begin, I have a few questions for you, just to keep it a little bit interactive. So, do we have here anyone who has never ever in their entire life been in a car? Like never ever. Okay, I thought so. So who here uses a car, let's say from time to time? You want to make a trip to Kutná Hora, which I highly recommend, by the way. You take a car, you go. So hands up. Okay, a lot of people. Who here uses cars regularly? So on a daily basis, you drive to work, etc. Okay, some people with children as well, because those are mostly the ones. Who here loves cars? Do we have any car enthusiasts? Okay. So, great. So, irrespective of your relationship to cars, these vehicles have become an integral part of our lives. They have really transformed how we cover short and medium distances. And in the car industry, there are a lot of buzzwords, and my approach to this presentation was to give you a little bit of a realistic look about the car industry and about what it means and how it operates, and just to look a little bit behind those buzzwords. So first, let's cover a little bit about the future of cars. The future of cars is told to be EXE, which means E stands for electrified. By 2030, we estimate that 55% of new car sales will come from fully electric vehicles. A means autonomous. So by 2030, we estimate that about 40% of our kilometers will be covered by the vehicle autonomously. The EXC, so the C stands for connected, so cars will talk to each other. S means shared, and Y means updated yearly. So the idea here is that we will build a car that is full on spec, and you will purchase some parts of it. So if I have my key and I will put it into ignition, and I have bought massage seats, for example, then I can use them. And if you have bought, for example, Google Maps, then if you put your key in the ignition, then you will have Google Maps in the system. So that's about the future. I'll need to, okay, 5 minutes, so let's skip this part. However, many new technologies are available as of today, are in production cars, and they're government approved. I have chosen just one to give you a little example. Okay, will this work? So these are called dynamic matrix headlights. They consist of 1 million pixels. So these images are projected by our headlights. This is, by the way, a production car. It's fully electric. It's manufactured by Audi. So there's actually a sensor in the front bumper which estimates if you are in front of a wall or if there's no wall. So if there's no wall, it projects it on the ground. So you have the customization options, which are really nice. So if you have the money, you can buy this car right now. I don't actually, so that's a problem. But hopefully one day. But this is just the tip of the iceberg. There are many new technologies coming and the future is exciting. Yeah, you have like, I don't know, 5 options. This one is called origami, by the way. So what can we use this for? For example, this technology, if it detects you're on a highway, it illuminates your lane. And I don't know if it can be seen in the video, but there are like small black arrows in the light so that you subconsciously stay in the middle of your lane. So it is scientifically proven that if they put these little arrows there, that you drive like more in the middle of the lane. So this is the vision. Again, I'm picking Audi here, but it doesn't really matter, that cars will communicate with each other and they use, for example, these headlights. So also, if this car is behind you, it can use its high beams to illuminate everything around you, but it uses a cone of light not to dazzle you. So these are technologies of the future which are available right now. Okay, a little bit about the automotive industry in the Czech Republic. Some little facts. So in 2018, more than 1.4 million cars were produced in the Czech Republic, which means that we are in the 5th place in Europe. The first one is, of course, Germany, which produces about 8 million cars. The position of the automotive industry in the Czech industry is very important. I just realized I have my presentation right there, so I can look there. It's very important because like 1/4 of the whole industry is in the form of the car manufacturing. So you can view it as, so for example, if we take everything that's being produced in the Czech Republic, like 1/4 of the value will be cars. Okay, so the car industry contributes 9% of the GDP. It employs more than 160,000 people directly, and there are many more indirectly, for example, logistics services, and it involves more than 800 companies. Okay. The most important factor in the car industry are actually not the car manufacturers, Škoda, Hyundai, or TPCA themselves, but their suppliers, which create this really intricate network of connections. I have a question. Does anyone recognize any brand, but in the industry? So, because Bosch also produces some toolings and also washing machines, I think. So does anyone know at least one and what it produces? Okay, so a fair amount of people. Great. Now, a little question. We have time for it, so let's do it like right here. So Škoda employs about 34,000 people here in the Czech Republic and or worldwide, actually worldwide. So there are 34,000 people working for Škoda worldwide. And now my question is, how many people worldwide are there working for Bosch, for example? And I'll give you like 3 options. Less people, about the same, and more people. So who thinks that less people are working for Bosch worldwide as a supplier? And bear in mind, they just create like smaller parts for the cars and they sell it to the car manufacturers. So they're smaller. So who here thinks that there are less people working for Bosch worldwide as a supplier than for Škoda? Someone? Okay, thank you. About the same? Okay, so few people about the same, and more people. Okay, let's say substantially more, so 8 times more. Who would say even 8 times more? Yeah, some people, okay, some extremists. Actually, it's, yeah, actually it's true. There are more than 250,000 people working in the Bosch Automotive division worldwide. So this really gives you an example. Bosch has more than 460 factories worldwide, so this gives you really an example of the scale of the suppliers. Okay, we'll skip this. Actually, Bosch in the Czech Republic has 5 factories. The biggest one is in Jihlava. It employs about 5,000 people, and there's also one in České Budějovice. About 4,000 people are working there. They're mostly doing fuel systems and accelerator pedals, etc. So if I want to share one idea in this part with you, then it's that these suppliers are really the bread and butter of the industry. They create most of the value, and also they do most of the research and development. And these are just the biggest companies, the biggest suppliers, and even they have their own suppliers, and the suppliers have their own suppliers, so it creates this really huge network of suppliers, basically. Okay, we're good on time. Now, to the second part of my presentation. What I'm going to show you now is a data science project within the automotive industry. I will explain each and every slide for you, but just to give you a little context, I cannot name the company, but they produce parts made from plastic, which are about this big. Air is flowing through them, that's all I can say, and they're housed within the engine compartment. So it's a supplier with about 1,000 people, so it's a medium-sized factory producing plastic parts. And our objective here was that there was problem with waste. So if the product, the plastic part, has some defect or a bad color or whatever, it's considered to be waste, and it needs to be handled separately. So what we did, and when we started with the project, was that we wanted to really evaluate the statement. The hypothesis was, okay, there was more waste coming to the system, and I will explain this graph really quickly. The blue line you see there is separated waste. So if the waste is created, you can separate the plastic parts, and then you get money for it. But if you keep it all together, there are more oily parts together, and the waste is considered to be contaminated, which are the red bars, and you need to pay for the contaminated waste. So the idea is separate as much as you can and create the least amount of waste you can. So what we can see here, I don't know if my cursor is there a way I can... Okay, so what we can see here, this is the part where we started, basically. in October, there was a huge program to increase the production of plastic parts. And as you can see, the waste raised substantially and raised more than the production rose. So there was a problem. So we had confirmed the hypothesis that really the waste went up. And the unfortunate part was that that not just only the separated waste went up, but also the contaminated one. So the company was giving a lot of money to get rid of this waste. So where's the data science in this part? You ask me. Well, there was a lot of data mining because they have 4 independent information systems. So we need to connect to each system. Some of them are bought. Some of them were coded by the brother of the guy who was head of the IT. So there was no documentation. You didn't know like what to do. So we needed to get it everything together. By the way, the whole software I will talk about was written in Python. It uses Django as a web server, so everything was Python ready. Okay, so guys, do you follow me? Like, is anyone lost at this point? We're okay, we're cool, okay. Now, if you can tell that the information system doesn't give you enough information, then you really need to go to the place and just watch the physical flow of the material. Just to explain this slide really quickly, what you see in the blue boxes is the basic process. So you produce the part, you assemble more parts together by hand or by machine. Every part is 100% quality control, so every part needs to be inspected. Then it gets warehoused, then it gets loaded on a truck and sent to a customer. What's important on this slide is that waste can be created at 14 different places, and it all gets together at a sorting place. So we have absolutely no idea what's the source of this waste. So that's the most important thing on this slide. So what we tried to do, okay, there was some process mapping done. So that was the data science part. I will explain it later a bit. So what we tried to do, we took the information systems and we said, okay, we know how many products we produce. The question is, if we know on average the weights of different products, like how many waste can we get from the system? So how many waste is actually in the system, is recorded in the system? So we took the 14 different parts. By the way, a funny thing here is that I was wagered that I cannot put a picture of human excrement in the presentations, and actually I won because I did. I cannot see my cursor, but actually the material degradation, there's a little pictogram of poop, so yeah, I won. But this is really important in the project because you're working with real people and they need to see that you have a sense of humor, and then you are a normal human being. You're not just an external consultant doing some data science stuff there. So it was really important. So what we did here, we aggregated all the data and found out that from the 52 tons that were reported by the waste system, only 33 are recorded in the information system. So waste is gone somewhere. We don't know where. So basically this slide reiterates the idea that we needed that 34% of our waste was just gone. We didn't know where it was. The data science part in this was, for example, there were about like 4 waves of people really recording in the information system, and some products had their weights associated with them and some did not. So for example, we created a simple machine learning model. It was a XGBoost regressor which had about 30 features, and from the parts we did not know the weight of, it estimated the weight of the parts. So there was a lot of machine learning actually in the background. Okay, so if our information system is really in a state which can be called catastrophical, what can we do about it? Because we need to control the waste, we need to know how much waste are we actually producing. There are basically two approaches to this problem. The first one is called top-down. So you shut the factory down and you clean all the systems and you begin anew. As you can suspect, this was not the preferred solution. So we went with something which is called bottom-up. And this means that there are only two ways for the product to leave the factory. Either it is a good product and it's being shipped to a customer, or it is a not good product and it ends up in waste. There are not many more ways. So if we control the customer, and the customer is easy to control or easy to talk to, because if you send him bad products, he will make a complaint. And if we have also the waste process under control, then you can safely start to really uncover where the waste is going from the system. Is anyone lost at this point? Are we okay? Great, okay. So we started with the bottom-up approach. So control waste, report waste every day. So daily waste handling. So we devised a little simple plan. The first step was just to start sorting, because you need to stop the bleeding first. And having so much contaminated waste was really one of the objectives of the project. The second part was weight tracking, because we estimated most of the weights. So we wanted to have an idea like how much weight and how much waste is created by each production line. The third one was source tracking. So we wanted to know where this waste comes from and which products are really defectuous. And the fourth, the last one, were optimizations. So there was a simple system coded in Python, as I mentioned. It aggregated all the data. There were about 4 web interfaces. Many people interacted with the system, so the reports were absolutely automatic. And just to explain this slide, this is our daily report that we started to produce. And you can click actually on every of these bars, and it will show you how much of every product or how much of every type of waste is there. So finally, we have some data. Okay, so last but not least, these are the results of the project in May. So as you can see, before we had information about the waste just after 2 months, because the systems were just so slow and it was calculated based on the invoice of the contractor which was taking the waste from us. With our system, we had it basically real time, most of it was calculated in batches each hour. So after each and every shift, we could say, okay, these products were really problematic and they need to be taken care of, and these products were good. And as you can see, we also shifted the blue bar, red bar ratio. There was more than 10 tons more separated waste, which amounts up to about 6,400 euros monthly, which is about 64,000 and it's about 75,000 euros yearly, which is not that much actually for these types of projects. if I did something with production or actually influence the production line directly, I would like something in the realm of 5 times to 10 times more just to be a successful project. But this was something that the company really needed. So let's say the money was not that hot, but it was pretty nice. So just some key takeaways from the project, or let's say key lessons. If you're doing a data science or an ML project in the industry, you really need to possess deep technical knowledge of the production processes. And that's one of the biggest problems with new startups trying to get into the automotive industry as a whole. Also, machine learning or data science needs to be packaged as an entire deal and as an enabler of value. So you use these models to bring the company the money. The management actually doesn't care if it's written in Python, or actually what kind of machine learning it uses. The only thing they're really looking forward to or looking at is the money that the service brings to them. And this is like one of the sad realities of the job. So integration and project management is just as important as the algorithms. You really need to get the project team on board. So that was the little poop thingy there you saw. Yeah, it's a small part, but it's really important just to get all the people on board, because those people will use your system after you are gone from the factory. And for last but not least, projects cannot be handled remotely, like mostly. Some companies do like 40% remotely, but what I like to do is really to spend time with the people in the factory and to be there. So that's all from my part. If we have any questions, I hope this was beneficial to you.
Thank you, Andrej, for the talk.